Alright, this is the 2006 AB number 3 FRQ. I'll start by reading the question. So it says the graph of the function f shown above consists of 6 line segments. Let g be the function given by g of x equals the integral from 0 to x of f of t dt. So up here we have a graph of f. In part A, we define g of 4, g prime of 4, and g double prime of 4. Okay, so before we start, I'm going to go up here and say f, since we have the equation, is actually equal to g prime of x. Because we can solve that by taking the derivative of both sides. So it'll be handy to know as we go throughout. So our first part, since we have the equation for g, we'll just plug it in. G of 4 equals the integral from 0 to 4 of f of t dt. So we're looking for the area under the curve of f from 0 to 4. So from 0 to 4. That's easy because these two triangles are symmetrical. And this one is below the x-axis, this is above the x-axis, so they will cancel. That one and that one will cancel. And then we have to find the area of this rectangle and the area of this triangle, and that'll be done. So the area of this is 2 times 1, which is 2. And the area of the triangle is 2 times 1 divided by 2, which is 1. So 2 plus 1 equals 3. G prime of 4 equals, take the derivative of both of these, equals f of 4. So we're looking at the point of the graph where x equals 4, which is 0. And then g double prime of 4, take the derivative again, so g double prime equals f prime. So we are looking for, at 4, we are looking at the slope of this line here, which we can get from the equation y2 minus y1 over x2 minus x1. We're using 5, negative 2, and 3, 2. So our y2 is negative 2. Our y1 is 2 over 5 is our x2 minus 3 is our x1. And you could leave it like that on an AP test, but we'll solve it for and it equals negative 2. So that's part A. So we'll look over here to the scoring guide real quick. You can see you get 3 points. 1 for the correct g of 4, 1 for the correct g prime of 4, and 1 for the correct g double prime of 4. And we got 3, 0, and negative 2. Those are our first 3 points. Part B. Does g have a relative minimum, maximum, or neither at x equals 1? Justify your answer. So to have a relative minimum or maximum, we need g prime to change sign. So at 1. So we'll look here at 1, and since this is a graph of g prime, we can see easily that it does change sign. It goes from negative to positive. So just a visual of that. We start with a negative slope, and then we'll gradually go into a positive slope. So we can see right here, that would be at x equals 1, would be a minimum. So we can write out g has a relative minimum at x equals 1 because g prime, or f for that matter, because they're equal to each other, changes from negative to positive at x equals 1. So that's our answer for part B. We'll go over with our scoring guide to see how many points we got for that one. We got 2 points, 1 for the answer, 1 for the reason. So even if you got the right answer, you have to justify to get that extra point. So that's a total of 5 points now. Okay, so now we've done part A and B. We're going to move on to part C. It's the toughest part of the FRQ, but it's still doable. So I'll read it. Suppose that f is defined for all real numbers x and is periodic with a period length of 5. The graph above shows 2 periods of f. So that makes sense. We have a period length. This graph is going to be periodic with a period length of 5. So basically, every time x goes 5 x values, it's going to repeat itself. So we can easily see that the first 5 x values, you have this, and then the next 5 x values, it repeats itself, and it's just going to keep repeating itself every 5 x values. So that'll come in handy. So the first thing we have to do in part 3c is we are given g of 5 equals 2. And we need to find g of 10. So we have the equation up there still. G of 10 equals the integral from 0 to 10 of f of t dt. So this problem is actually very easy since now we know that f is periodic. So basically we know that g of 5 equals 2. So we know that from 0 to 5 the area under the curve is going to equal 2. So g of 10 would be g of 5 times 2 since it's from 0 to 10 instead of 0 to 5. So that makes it really easy. G of 10 equals 2 times g of 5. We know g of 5 equals 2, so g of 10 equals 2 times 2, which is 4. So that's the first part of our problem done. We'll put that up in the square. The second part's a little harder, but still very easy. Oh, so now we have to write an equation for the line tangent to the graph of g at x equals 108. So every time we're doing an equation for a tangent line, we need two things. We need a point, and we need a slope, and then we're gold. So we have our x value. Now we need our y value and our slope. So the first thing we're going to do is we're going to find g of 108, using our equation up here still, equals the integral from 0 to 108 of f of t. This problem is actually very easy now, since we now know that the graph of f is periodic. So we have g of 108. We're going to break this up into two pieces to make it a little easier. So we're going to break it up, and the first piece is every full period. So we're going to do it from 0 to 105, because that'll be 21 full periods. And then we're going to add the remainder, which is 105 to 108 of f of t. Okay, so the first one, we know this is going to be 21 periods. And back over here, we know that one period from 0 to 5 equals 2. So we know it's 21 periods because 105 divided by 5, that's how many periods it's going to be. And then times 2, because we know the area for each period. So that's our first integral done. And now we need the remaining that's not a full period. So we need 105 to 108. Well, 105 is the start of a new period, so we can start over here, like this is 105. Then we'll go 106, 107, 108. So we need the area of this rectangle and these two triangles. We know that these two triangles cancel because they're symmetrical. And then we have this rectangle, 2 times 1 is 2. So we know that the area is 2. So we basically have g of 108 equals, this equals 21 times 2 plus 2, which equals 44. So that's our y value. Last thing we need to do is find our slope before we write the equation. So we're looking for the slope, g prime, at x equals 108. And we know that from this equation up here, we know that g prime of x equals f of x. So we know that g prime of 108 equals f of 108, which f of 108, we can go up here since we restarted before at 105, because that's the start of a new period. So this would be 105, 106, 107, 108. So f of 3 is the same thing as saying f of 108, since we know that f is periodic. We know that f of 3 right here is 2. So we know our slope at 108 is 2. So now we have our point, we have our slope, and the last thing we need to do is write the equation of the tangent line using the formula y minus y1 equals m x minus x1. Now all we need to do is substitute in and we're done. So y minus our y value of 44 equals the slope of 2, x minus our x value of 108. And that's the equation of our line tangent to the graph of g at 108. Last thing we'll do is go over here and check our scoring guide. So we have our 4 points in part C, our first one coming from finding g of 10, which is 4. And then we have 3 points for finding the second part. Our first point of finding the y value at 108. The second point for finding the slope at 108. And the final point is for putting it all together and writing this equation of a line. So that is the full FRQ for AB 2006, number 3.